When the ancient Greeks looked at the night sky and saw that some lights wouldn't stay fixed against the background, and instead moved around the sky every night, they named them planets, which meant wanderers. Even before, Babylonian astronomers had already made extensive observations of the motions of these wanderers, identifying Venus, Mercury, Mars, Jupiter, and Saturn as soon as the 7th century BC, but Uranus and Neptune, due to being further away from Earth, would only be identified millennia later by astronomers using telescopes in the 18th and 19th centuries. And ever since then, we've been on the hunt for the next planet orbiting the Sun. Recently, new evidence heated up the debate once more, as some astronomers are becoming increasingly convinced there could be, in fact, a true Planet 9. There are two ways you can find a planet in our solar system: by observing it moving relative to background stars, or by calculating disturbances in another planet's orbit. Ancient astronomers were already able to identify the planets from Mercury to Saturn, but finding Uranus and Neptune was a bit trickier. Uranus is still somewhat visible to the naked eye, but it was never recognised as a planet by ancient observers because of its dimness and slow orbit, taking more than 84 years to complete an orbit around the Sun. It was only in the 18th century when astronomers were able to track its movement, finally discovering the planet. Neptune, meanwhile, was found using math. When Uranus's movement deviated substantially from its calculated orbit, French astronomer Alexis Bouvard hypothesized that an unknown body was perturbing the orbit through gravitational interaction. After a few decades of calculations and observations, astronomers found Neptune in the exact spot of the sky where the math indicated it would be. But the astronomers weren't done. Later in the 19th century, subsequent observations of the ice giants led astronomers to speculate that Uranus's orbit was being disturbed by another planet besides Neptune, so the search for Planet X, as it was dubbed, began. Some decades later, in 1930, astronomer Clyde Tombaugh searched the solar system for over a year through the daunting process of systematically imaging the night sky in pairs of photographs, then examining each pair to determine whether any objects had shifted position. Using a blink comparator, a viewing apparatus that permits rapid switching from viewing one photograph to another, essentially blinking back and forth between the two, Tombaugh discovered a possible moving object on photographs from two different dates. This was later confirmed, and thus Pluto was discovered. However, the new planet's faintness and lack of resolvable disk cast doubt on the idea that it was Planet X, the one responsible for Uranus's further orbital deviations. Initially thought to be roughly the mass of Earth, improved measurements revised Pluto's mass downward throughout the 20th century. Now we know Pluto to be even smaller than our own moon, far too tiny to influence the orbits of giants like Uranus or Neptune. In 1992, this orbital mystery was finally solved when mathematical astronomer Miles Standish used data from Voyager 2's flyby of Neptune, which had revised the estimates of Neptune's mass downward by 0.5%, an amount comparable to the mass of Mars, to recalculate its gravitational effect on Uranus. With the new figures added in, the discrepancies, and with them the need for a Planet X, vanished. Even worse for Pluto, in the beginning of the 21st century, discoveries of other trans-Neptunian objects of similar size like Eris, Haumea, and Makemake cast doubt in its classification as a planet. So in 2006, the International Astronomical Union created an official definition for the term planet, which removed Pluto from the roster. It now joins the ranks of Ceres, Juno, Pallas, and Vesta, which were once considered planets as well during a brief period in the 19th century. And with this, the matter of the 9th planet was finally settled, for a time. Science rarely stays the same for too long, and a few years later a new mystery would appear in our solar system, one that would bring back the Planet X discussion. The Kuiper Belt is a disk of asteroids starting close to Neptune's orbit and extending to about 50 astronomical units from the Sun, Similar to the inner asteroid belt between Mars and Jupiter, it consists mainly of small bodies or remnants from when the solar system formed, but it's much larger, 20 times as wide and up to 200 times as massive. The first Kuiper Belt object was found in 1992, and since then, astronomers were able to detect hundreds of thousands of asteroids, comets, and dwarf planets residing in the belt. As more Kuiper Belt objects were found, however, one strange pattern began to emerge. Many of their orbits seemed disturbed in a way that only a large mass could be responsible. The gravitational effect of a sizable planet could explain this unlikely clustering of orbits for a group of extreme trans-Neptunian objects, known as ETNOs. This Planet 9, as it became known, could be shepherding the orbits of the most distant known solar system objects, causing them to veer into this highly elliptical shape. In 2016, astronomers Konstantin Batygin and Michael E. Brown suggested that Planet 9 could be the core of a giant planet that was ejected from its original orbit by Jupiter during the genesis of the solar system, now orbiting the Sun in a highly elliptical orbit, roughly 13 to 26 times the distance from Neptune to the Sun, which would make the planet take between 10,000 and 20,000 years to make one full orbit around the Sun. To be able to interfere in so many ETNOs in these specific ways, they estimate Planet 9 would have 5 to 10 times the mass of Earth and a radius of 2 to 4 times the Earth's. Now, with its orbit and size estimated, we just have to find it. If it exists, Planet 9 would be so distant from the Sun that it would reflect very little sunlight, potentially evading telescope sightings. Astronomers estimate the planet would have an apparent magnitude of less than 22, making it at least 600 times fainter than Pluto. This might be slightly beyond what our current telescopes can see, but a new generation of observatories is already being built for that exact purpose. The Vera C. Rubin Observatory is a giant telescope currently under construction in northern Chile, and it'll have a wide-field, 8.4-metre primary mirror capable of photographing the entire available sky in just a few nights. The observatory's mission will be the Legacy Survey of Space and Time, or LSST, a 10-year continuous survey of the southern sky, gathering data about the mysteries of dark energy and dark matter, the formation of our galaxy and the properties of small bodies in the solar system, the trajectories of bigger and potentially threatening asteroids, and the existence of Planet 9. However, what the LSST finds might end up not being a planet at all. Instead, it could be something far weirder. We already talked about black holes before, including the first ever direct imaging of one, but there are some weirder types of black holes that could exist since the beginning of time. In the early universe, very soon after the Big Bang, matter was so tightly packed together that any irregularity in density could have led sufficiently dense regions to undergo gravitational collapse, forming black holes. Since these primordial black holes didn't form from stellar gravitational collapse, their masses could be far below stellar mass. In 2019, a paper by astronomers Jacob Schultz and James Unwin investigated the possibility that Planet 9 could, instead of a planet, be one of those yet undetected primordial black holes. A few months later, another team of researchers at the University of Tokyo reanalyzed data from the 5-year Optical Gravitational Lensing Experiment, or OGLE, a research project that images the sky using advanced telescopes over long periods of time. The team was trying to explain an excess in microlensing events on the OGLE's data, a form of gravitational lens where the light from a background source is bent by the gravitational field of a foreground lens to create brightened images. Their conclusion? There is evidence to suggest that primordial black holes of similar mass to Planet 9 could exist. Their sizes would be extremely small, less than 10 centimeters across, but their gravity would still be powerful enough to disturb nearby objects. By interacting with surrounding dark matter, these tiny black holes could turn it into gamma radiation. Thus we could detect them with instruments like the Fermi Gamma Ray Space Telescope, or the LSST. Searching for new planets in our solar system has always been one of the holy grails of astronomy, and even today that hasn't changed. The new evidence for a Planet 9, or even a possible new type of black hole, excites scientists all over the world, and the next generation of groundbreaking surveys like the LSST are perfectly suited for the job, so we might have a definitive answer in just a few years. Perhaps by the next decade, science books will change again, and the solar system will have 9 planets once more, or a slightly cooler, darker, and tinier equivalent. Thank you for joining us in this episode of Access Astronomy. We hope to see you here next time when we continue to point our telescopes at the sky and seek out the mysteries of the universe.